This section we're talking about savings accounts. And savings accounts all pay interest. We talked about, some checking accounts do and some checking accounts don't, but savings accounts all pay interest. Interest rates depend on the bank, and it also depends on what kind of savings account it is. And the reason that the banks pay you interest on your savings account is because they're paying you for the right to use those funds, to make loans to people or do other bank business. And because they're expecting the funds to be there, that's the whole point. We pay you interest, we expect the funds to be there. Savings accounts are really meant to be a long-term account. You're supposed to leave the money there. The checking account is the account that the money can flow in and out of. Your savings account is supposed to just sort of sit there, and you put money in it, and you just leave it sitting there for later, long term. And that's why they pay the interest. A lot of banks, if you have too many transactions on your savings account as far as money coming out, you'll get charged penalties, or they simply won't allow it. My bank has a 3 withdrawal a month limit on savings accounts. So if you withdraw money from your savings account 3 times and you want to go withdraw more money from your savings account, you can't. It's impossible. You can't. They just won't let you. You have to wait till the next month. Interest is the money that the bank pays you. It's paid at a specific percent. And I wrote on certain types of bank accounts because, all savings, but not all checkings. And there are money market accounts, CDs, different types of accounts that we'll talk about. The interest rate is the percent rate of interest paid. Typically, it's advertised as APR, annual percentage rate. And then the principal is the money that is deposited into the account by the account holder. So interest gets deposited into your account, but that's from the bank. Principal is the money that you put in your account. And simple interest calculates interest on the principal only. So the interest that you're earning on your savings account is only from the money that you're putting in there. It doesn't count any interest that the bank has paid in there. That's simple interest. Now there's another kind of interest that does pay interest on interest. Does it sound weird, interest on interest? But this pays interest on your deposits. The other kind of interest, which we'll talk about, pays interest on the balance in the account. And so there's two different types of calculation and 2 different originations of money. So this only pays money on your deposits. Any questions about that so far? The simple interest formula, I equals PRT. I is the interest earned. Okay, this is a dollar amount. P is the principal, also a dollar amount. R is the rate, and this is a percent converted to decimal. And T is time, and this is in years. Okay, and it has to be years. So if you're given some amount of months, like 6 months, you do half a year. It always has to be years. Okay. Savings statement, you'll get those. Some banks will send you the monthly statement, and your checking account and your savings account statement are on the same statement, just they'll have like a line dividing them or something. And then some banks send separate statements. And then if you have electronic banking on, you get your statements online, they'll definitely be separate. This is just like a checking statement, basically. Okay, it's a monthly statement that shows all out account activity. It'll tell if you've earned any interest. Okay. And then any deposits that you've made, etc. If you're the bank, ideally they don't want to be reporting on any withdrawals. They want you to just keep money in there. Minimum balance. Most banks require a minimum balance in a savings account. Now, it may be very small. The minimum balance on my savings account is $5. Very small amount of money, but I have to keep $5 in there. And then when I look up my savings account balance, that $5 doesn't even show. It's just, they just keep it on reserve. Typically, if you go below the minimum balance, you have fees. Okay, and then some accounts have fees anyway. Okay, money market account. It's a type of savings account, but it's not a straight savings account like you think of when you normally think of just a basic savings account. You think like, okay, I go and I put money in this account, it just sits like in a vault somewhere. Right? It's just there, it's just sitting there. Money market accounts pay higher interest. They typically have higher minimum balances and higher minimum deposits to open. Okay, so you do earn more interest, but they require higher initial deposit and a higher minimum balance. And typically, most of these are a type of investment account. Okay, and the type of investments and those details will vary depending on the bank and who's managing that account. But usually what happens is, it's not like a stock account where you're buying set stocks in certain companies and you own now, 50 shares of whatever. They pool all the money together from the money market accounts, and somebody invests that money on behalf of all of the account holders, and then that interest, it's very kind of complicated, but all the money market account money goes together and is used for investing by the bank. And then you get paid interest for the bank having the right to use your money for investments. So that's another kind of savings account. Like I said, it does pay higher interest. They're not music CDs, they're other kinds of CDs. A CD is a certificate of deposit. It's called a CD. Okay, and it's a type of savings account. Okay, and they're at set denominations, these accounts. $50, $100, $500, $1,000. It depends on the bank. I think there's 250 and things like that. And what happens with a CD is you have a set amount of money let's say $100, and you want to buy a $100 CD. Okay, so it's a set denomination, so you have to have the set amount of money, and you put it on deposit for a set amount of time. So, for example, I'm going to buy a $100 CD for 5 years. What happens is, I'm going to get a higher interest rate on that $100 than I would if I just stuck it in a savings account. The difference, though, is I can't touch it for 5 years without paying massive penalties and pretty much losing not only the interest I would have earned, but probably a big chunk of that $100 as well. So the CDs are, you're locked in without paying penalties. So you do get a higher interest rate, but then the bank has a guarantee that they have that money of yours for however many, there's a 1 year, 2 year, 5 year, 10 year CDs. So they'll pay you a higher interest rate because they know you're not going to want to touch that money because you don't want to pay the penalties and end up losing money. You're trying to earn money. And so you have it for a set amount of time, and that's what's the maturity date. And again, that varies depending on the CD you buy. There's different amounts and different lengths of time. The higher the length of time, the higher the interest rate. I believe they have $50 CDs. I believe so. It might be 100, but the longer the length of time that you have the CD go out for, the better the interest rate, because the bank knows, okay, well, if you do like a 10-year CD, we've got this money to play with for 10 years that we can't touch. So they're willing to pay a little higher interest rate to get you to buy into it. So these are good for long-term investments. You know you're not going to need to touch the money for any reason. You know you're trying to pay for your kid to go to college in 15 years. So you can have that money sitting there for that long. Or if you know you're going to buy a house in 5 years, you can do 5-year CDs for the down payment. You know, things like that when you know you're not going to want to touch that money or need to touch that money. Okay, so penalties. And like I said, depending on the amount of the CD and the length of time that you've had it in, like it's like a prorated penalty. You know how they prorate things? You guys know what I'm talking about when I say prorate? Okay, so if you go to rent an apartment and you move in halfway through the month, you don't pay a full month's rent, you pay half the month's rent. That's prorated. So same thing with a CD. If it's a 5-year CD, your penalty if you come out of it the first year is going to be different than the penalty if you come out of it like 4 years and 6 months. They prorate it. But if your CD wasn't for that much money and you didn't earn that much interest on it, you could actually lose money if you break out of it early. So you don't want to do that. And then maturity is the specific date that the CD can be cashed out. Some people, when they hit the date of maturity, will just roll right into another CD. So if they're like doing 5-year CDs, they'll roll the CD and the interest they earned into another CD. You know, just they keep rolling them in, so they keep earning that interest. Some people cash them out. Just depends on what your goals are. The earliest is 7 days. As you can imagine, that does not pay a lot of interest, 7 days. Up to 10 years. CDs and bonds are very similar in that regard that they have a maturity date. So bonds have a maturity date, CDs have a maturity date. Okay. Grace wants to deposit $5,000 in a CD for a period of 2 years. She's computing the interest rates quoted by 3 local banks and an online bank. And we want to figure out which one pays the highest, and we've got decimals and fractions. So you have 2 options. We can make them all decimals to compare them, or we can make them all fractions. Which do you guys prefer? Decimals or fractions? I got 1 vote for fractions. You have been outvoted. Sorry, I'll do it both ways. Okay, so fractions to decimals. Okay, so to go from a fraction to a decimal, you're going to divide numerator by the denominator. Okay, so this 4 1/4, I'm going to do 1 divided by 4, which is going to give me 0.25. This is 4.25%. And this 4 3/8, I'm going to do 3 divided by 8. Oh, I wish I'd forgotten it. 0.375. So this one's going to be 4.375. So now we can compare them. Ascending order means least to greatest. Descending means greatest to least. They keep going. Descending is going down, ascending is going up. So least to greatest. We have 4.25, 4.22, 4.375, and 4.3. They're all 4. These are both 2s, so I have a 2, 2, and a 2, 5. 22 is smaller than 25. So Johnson comes first. Okay. Then, oh, I was supposed to write the interest rates in something more. Sorry, I didn't mean to keep bank. So 4.22 comes first. And then 4.25. And then 4.3. And then 4.375. So which one is the bank that pays the highest interest? Easy. And if all other considerations were even, eSave is the bank that you would want to buy the CD with because you'd earn the most money. Of course, that's not the only thing you want to take into account. You do want to look at like the penalties just in case there's an emergency and you need to take the money out of the CD early. You want to look at the other kinds of features of a bank. Okay, Raul has a savings account that has to have a $500 minimum balance, or he gets charged a fee of $4. His balance was $716.23, and he withdrew $225. So what's his balance? Okay, new balance is $491.23. So he fell below the $500, right? Which means he's going to charge a fee. So we actually have to take his $491.23 and take another $4 out for the fee to find his actual balance. Because as soon as he hit below 500, that bank is going to charge that fee. So we have to put that in there too. So he actually is at $487.23. Okay, simple interest. It's called simple interest because, well, it's simple. It's not hard to calculate, and it doesn't take into account other factors like making deposits and withdrawals during the course of the time that you're talking about. It's just very, okay, you put this much money in the bank, and then you don't touch it for 5 years. You never put any more money in, you never take any money out, you just stick it in a bank account, you forget it's there, and here's how much interest you earn. So see, it's not very realistic, because most people don't do that. You don't just stick some money into an account and then you never touch it for years. You usually either end up taking money out or putting more money in. So the calculations that we do for simple interest are just kind of very vague in general. Okay, so Mitchell is going to deposit $1,200 into an account that pays 4.5% interest, simple interest. He's going to keep the money in there for 3 years without any deposits or withdrawals. And we want to know how much is going to be in the account at that point. Okay, so our simple interest formula is I equals PRT. 1,200, that's P. 4.5% is R. And then 3 years is T. Okay, so principal is the amount you deposit. Our rate, though, it has to be converted to a decimal. So we move this decimal 2 places to the left. And so it's actually 0.045. Just remember, we can't add, subtract, or we can add, subtract percents from other percents, but you can't multiply percents or divide percents. So you have to convert them to decimals before you can do that. So our interest is 1,200 times 0.045 times 3 years. And that's going to give me $162. But the question is, how much is in the account after 3 years? The account balance is the initial deposit plus the 162 interest. So in 3 years, he'll have $1,362. Okay, so simple interest, but we want to know 7 months. Okay, interest is equal to PRT. T is years. I don't have years, I have 7 months. So I have to find out how many years is 7 months. Well, there are 12 months in a year. So 7 months is equal to 7/12 of a year. So you just put it in fraction form. Okay, so I can plug it in that way. Principal, oops, I forgot to convert my rate. Take my decimal 2 places over. The easiest way to deal with a fraction in a problem like this is you're going to multiply 2,000 times 0.052 times 7. And then whatever answer you get there, then you divide by 12. So multiply all the numbers together times 7 and then divide it by 12 is the easiest way to do this. So I'll show that 2,000. Like that. That's the process. That's just the easiest way. You could convert 7/12 into a decimal and then try to have all the digits and stuff. It's just easier to do the multiplication first and then the division. So do 2,000 times 0.052 times 7, and then I divide that by 12. And I get $60.67 interest. Questions on that? How much principal must be deposited to earn $1,000 in interest in 2 years at a rate of 5%? This one's a little different. I have I, and I have T, and I have R. I don't know P. So I'm going to be solving this backwards a little bit. Same formula. Okay. Plug in my interest. I don't know my principal. My rate is going to be 0.05, and my time is 2. So what I get is I get 1,000 is equal to, I want to say 0.1. 0.1 P. Divide both sides by 0.1. And your principal is going to be $10,000. So in order to earn $1,000 in 2 years, you have to have $10,000 to put in the bank at 5% interest. Okay, so Derek has this account and it pays 4.1% simple interest, and we want to know how long it'll be. So when will the account grow to 1,000? So what we're looking for is time. Okay. I know the principal. That's how much money is in the account. And I know the rate. I don't know the time, so I need to know the interest. I don't actually have the interest on here yet. I know that I want the account to have $1,000 in it. But that's not the interest. The interest is going to be the difference between the balance we want and the balance we have. So $90. So now that I have all that information, so $90 is equal to $910 times 0.041 T, because I don't know time, so I'm trying to find. And that gives me 90 is equal to 37.31 T. I have to divide both sides by 37.31. So get 2.4 years, and you can leave it like that, 2.4. If you wanted to know how many months that is, you do 0.4 times 12, which will give me 4.8. So May, 5 months, roughly, 2 years, 5 months. Questions on that problem? Okay, Carrie's going to invest $5,000 in a simple interest account for 5 years, and we want to find out how high of an interest rate does she need to have $6,000. So she wants to earn $1,000 in 5 years. Okay, so we know that the principal is 5,000. We know that the time is 5 years. We don't know the rate. And the interest is going to be 6,000 minus 5,000. So 1,000 is equal to 5,000 R times 5. So 1,000 is equal to 25,000 R. You're going to divide both sides by 25,000. And you get 0.04, which we can convert into a percent, and that's a 4% interest rate. Okay, so compound interest is paid on the initial deposit and accumulated interest. So what it's actually paid on is the account balance. So if I had put $100 in my account and then I earned $10 in interest, then the next time they calculate interest, they would calculate it on $110, not just 100. So that's the difference. Simple interest would always just be 100. So if you put $100 in the account and then they calculate annual interest, it's just the interest on $100, $100, $100, $100. With compound interest, let's say it's earning $10 a year. The first year it would be $110. Then the second year, the interest would be calculated on the $110. So let's say that's $12. Then the third year, the interest would be calculated on $122, and so on and so forth. So it builds bigger, faster. There's annual compounding, semi-annual compounding, quarterly, monthly, and daily. Compounding is when they calculate the interest. So annual compounding, they calculate once a year. So let's say every December, they calculate the interest. Semi-annual compounding is twice a year, every 6 months. Quarterly is 4 times a year, that's every 3 months. Daily, 365 or 6, depending on if it's a leap year, times a year. And then monthly is 12 times a year. I would say probably the most common is monthly, for like savings accounts and things. But some banks do calculate daily, some banks do calculate annually. It just depends on the bank. Let's say you have an account that compounds daily. That doesn't necessarily mean they add the interest every day. Like they don't actually put the deposit into your account necessarily. They'll calculate it every day, but they might just put it in your account once a month or once a year. Now when they're doing the calculations, it does account for the money that they didn't put in. Like daily compounding only earns a couple cents a day usually, because of the way the calculations all work out. And so they don't deposit like 2 cents a day and then 2.5 cents tomorrow, and 3 cents the next day, and then 3.5 cents. You know, they don't do that. That doesn't make any sense. But they do the calculations as if they deposited it into your account, but then maybe they only put the actual money in your account at the end of the month or at the end of the year. That's when they credit you. Does that make sense? Computers keep track of it all. For our exploration of compound interest, we're still going to use the simple interest formula. So we want to know if we compound annually. So we're only going to make the calculations once a year. If I do just 1 year, I've got interest is equal to my principal of $1,000 times my rate of 6% times my time of 1 year. And what I'm going to earn is $60. Okay? And my new balance, you know, not the shoes, but the actual balance in the account, will be $1060. Okay? That's annual. If I deposit $1,000 that pays 6% interest, that's compounded semi-annually, so every 6 months. And I want to know the balance after a year. What I do is my time is equal to 6 months, not a year. So I need to put that in years, it's half a year. And the reason I'm using the 6 months is because of this semi-annually right here. That's what tells me that's how often the calculations are going to occur, so that's my time period. So I do 1,000 times my 6% times my half a year. And in that first 6 months, I earn $30. So my balance at 6 months is $1030. Because I put that $30 in there. Now my next 6 months, my principal is no longer 1,000. My principal is now $1030. My rate stays the same, and my time stays the same. But that's going to result in a different calculation because I'm going to earn interest on the $30 I earned in the first 6 months. And I'm going to earn $30.90. That's not a huge difference, but it is a difference because the balance at a year is $1030 plus $30.90. So the fact that they calculated twice in a year versus just once in a year earned me an extra $1 almost. You guys see that? So same deposit, same interest rate, 1 calculation per year, 2 calculations per year. And if we keep increasing that, and we do 3 calculations per year, or 4 rather, we do quarterly, or 365 calculations per year, you can see that that's going to be snowballing. You're going to get more interest that way, right? Okay. We've got $1,000. We've got our interest rate. Time is 3 months, which is equal to twelfths of a year, which is a fourth of a year, which is 0.25. Okay, so I'm going to do my 1,000 times my rate times a fourth of a year, because that's quarterly, 3 months is a fourth of a year. And I'm going to get $15. Okay. Now this isn't, this is just our balance at the end of 3 months. I want to show just how much difference quarterly makes versus semi-annually. And what would happen is our second quarter would be calculated on the 1015 instead of 1,000. Earning me 1523. That's the second quarter. And then the third quarter would be calculated on 10/30/23. Which would earn me 1545. These aren't huge differences, but it is a difference. Then the fourth quarter, which would be the last part of the year, will be calculated on 10/45/68. Oops. Hold on. So my balance at 1 year would be 1061.37. Same interest rate, same initial deposit, but instead of $60 earned, I got 61.37. And that's just because they did 3 more calculations than in a year. They did 4 instead of 1. This is daily compounding. 1 day. Okay, so we've got our $1,000 still. We've still got our same 6% rate, but I need to know what my time is. Time is 1 day. They didn't say leap year, so we're going to assume 365 days in a year. So it's going to be 1/365. That's 1 day. Okay, so for this problem, I'm not going to convert that into a decimal. I'm going to do 1,000 times 0.06 and then divide it by 365. That's just the easiest way for me to do that. $0.16. So in the first day, you would earn 16 cents. And then the second day, your balance would increase a little bit more because you'd earn interest on 1,016. Well, 16.44 cents, so still 16 cents. So you're going to average out about 16 cents a day for a little while, and then it'll go up to 17 cents a day for a little while, and then 18 cents a day for a little while. In the long run, it'll be worth more than $1.37. Because this is 4 calculations per year. This is 365 calculations per year. that pays daily interest at 3.2%. So on July 11th, she has a balance of $1234.98, and then she takes out $200. She gets $34 check from her health insurance company and deposits it. And then on July 12th, she deposits $345.77. And we want to know what her balance is on the end of the day on July 12th. So I'm going to have to calculate 2 days of interest compounding. Okay, so first we start with July 11th, and we start with $1234.98, and she takes out $200 and deposits $34. Okay, so her balance at the end of the day on July 11th is $1068.98. This is our principal for our calculation. Okay, our rate is 3.2%, so 0.032. And our time is 1 day, so 1/365. So our interest for this day is $1068.98 times 0.032 divided by 365. Alright, so on the first day, she earns 9 cents. Now on July 12th, hold on, we have to add the 9 cents in. So that's the end of the day on July 11th, once she's earned her 9 cents. So on July 12th, she starts out with $1069.07, and she deposits a paycheck. Okay, this is our new principal. Same rate, same time. So on July 12th, she actually earns 12 cents. So the balance at the end of the day is $14.14.